Welcome to the 13th topic. We're looking at databases in this video. If we have a look at what we need to cover for this topic, so it doesn't look like a massive amount, but there is a lot of information to get across from this topic, a lot of stuff to remember. Unfortunately, I guess this is one of the topics, and probably one of the few topics, where actually the content you're going to learn is probably harder than the questions you're going to get in the exam. Usually the content is okay, you can understand it, but then you'll get a tricky exam question, and I would like to think that actually this is maybe the opposite. Some of the stuff in this video is quite difficult immediately, but hopefully exam questions will be slightly more kind. And this bit at the bottom is just another bit from a specification clarifying exactly what you need to know about SQL, because this isn't too clear. So let's begin by talking about something the exam board actually wants to talk about. It seems a little bit pointless, but the idea is we can talk about data being structured or unstructured. And structured data is that's arranged in an organised, defined way. And the idea is that structured data is far easier for computers to interact with. You know, we have to be very defined when we're talking about data in a computer. So, you know, data types, we have to classify data in that way. And so structured data is much easier to process, whereas unstructured data has no kind of set layout for a computer to work with. And, you know, unstructured data cannot be easily mapped by a computer into certain fields, which is more relevant to databases. And the epitome of structured data is the database, and this is kind of our token database definition. I just googled this, the first one that came up. So a database is a collection of information that is organised so that it can be easily accessed, managed and updated, and this is us talking about SQL, which we'll look at later in the video. So this is just a screenshot of Microsoft Access and just a very small table here, which is it's something called a DBMS, a database management system. Not something you need to necessarily know, which is why I'm not going to talk about too much, but you might have got access on your computer, kind of thing you just have without realizing perhaps, but this is just an example of what some software to do with databases might look like. So now to kind of look at some definitions, unfortunately. So you need to know about a database model, which is the relational model. And so this is a database that consists of tables linked together with each other by key fields, and key fields is something we need to talk about a bit later. So two tables here. This is actually our key field, our primary key, subject ID in this case, but I'll explain this in a bit. This is almost a deliberately bad example. I kind of thought I might as well talk about it because this might be an exam question. Because really, this is just, you could just add this column onto the side, but I'm just trying to show you it's separated, so it's worth talking about. So this is some definitions you need to know. First one, a table, kind of a bit of a pointless definition, but there you are. So it's just a two-dimensional representation of data, so stored in rows and columns, but you can see that. A field is a definition you might need to know, or you might not know. So this is a single piece of data about an entity. An entity we're going to define at the bottom, which isn't too helpful, but an entity is just a real thing. That is literally the definition of it. And so a field is also a column. So there are some synonyms when it comes to database definitions. I'll show you that in a couple of seconds. So record is like a row, and this is a group of fields about a specific entity. So, you know, you can almost think of a field as a column, but when we're talking about a specific record, a field for that column is kind of the intersection between the column and the row. So this is what this is kind of trying to say. So just think of it as the row of a database. And so I've taken report just because there was a question in one of the sample materials about why a structured database is good, and just in my mark scheme I mentioned report, so it's worth defining. These are just presentations of data from a database, and having a structured database, especially when you're using a database management system like Microsoft Access, you have access to other tools like be able to generate reports of your data. And a query are requests for data stored in the database. Also, technically they're sorting, but queries is to do with SQL, which will be the last thing we look at in this topic. And an entity, as I say, is just basically a real thing about which data is recorded. So that could be a person, it could be an object, it could be a subject, etc. And so just to recap, because that might not be immediately clear. So we have a database that consists of tables. Each table contains multiple records, so we have lots of rows, and the records are made up of lots of individual pieces of data, as in the fields. And so just to clear up, this is just something that I got really confused with when I was sort of learning by databases in that you'll read a website, you'll go and watch a video on YouTube, you'll look at a textbook, and they all use different terms, different terminology. And this is kind of showing you the groups of terminology that can be used. And the example wants to talk about tables, it wants to talk about fields and records, instead of the other terms. And this is taken from a very popular textbook. I think it's called Database Systems. I had a physical copy once, and it had way over 1,000 pages, which kind of shows you the scope of the databases topic. It goes way beyond what we're covering in this video. So this might just help in case you'll get confused about what terminology is being used. So we're going to look at entity relationships now, and this is something I can't say for certain how much you need to know about. The specification just says relationships, so one word, not a massive amount to go on. But other exam boards do talk about what I'm going to talk about on this slide. And I think with databases, the more you can learn about, the more the easier stuff makes sense. And so it's better to learn as much as possible, even if it's stretching beyond what you need to know a bit. But we're going to talk about the entity relationship model. And so really this is kind of a bit like a plan. I would kind of link it to maybe pseudocode in the sense of you do it when you're designing a database, and really the idea is to identify entities and how they relate to each other. That's the relationship. So relational databases, the entities, so you'll have a table about each entity, and then they have different associations, they have different links. So as I say, the relationship is the link between entities, and so the tables are connected in relational databases, as I've said, and this is modelling the link between the entities in real life. And so we're going to talk about 4 degrees of relationships, and technically we're talking about binary relationships. So in terms of 2 entities, you can have tertiary, you can have quaternary, 3 and 4 entities respectively, and so on. We're going to talk about 2 to keep it nice and simple. So the first one is a one-to-one relationship, and sometimes written like this. And so, for example, in real life you have a single entity, the husband is married to the wife, and we tend to write this kind of, so this is our kind of plan, this is our kind of diagram to do. So maybe it's better to think about it more as a flowchart kind of planning diagram. And so usually we write the relationship as a verb along kind of a line, and we write the entity in a box, and it's a singular noun. And so this is just one-to-one. One husband is married to one wife, unless you're actually, let's not go into that. So a one-to-many relationship might be written as 1 to n. So an example, a single hotel can accommodate many customers. And this kind of notation is called, I believe it's called crow's foot notation. And you can kind of see where the crow's foot notation, where the name comes from. And so this is representing the many side, this is our one side. And I like this, and I've included this. There are other notations to express entity relationships. But I like this one because it kind of shows you what it might look like in a database. So I think of this as kind of sets of rows. So each record, so we have one record in one table linked to many records in another table about a customer or about customers. And so I kind of think of it as separate rows, if you can see that. Might just be me. So another one is a many-to-one, just the other way around. So we have many students attend a single college, a single school, whatever. And many-to-many relationship is one that we don't like in databases. We have to kind of split it up into, try and adapt it into another one. And so, for example, many channels display many different adverts. So the same advert can be displayed on many different channels, and a channel will display many different adverts. So it works both ways in this case. And so a table, also known as relation, going back to that little the terminology table we looked at before. So a table is a set of records and fields, as we've said, modelling an entity. And multiple tables in the relational model can represent these entity relationships using the key fields, as I kind of said. So like I said, I don't know how much you need to know from this slide, but if you can understand as much of it as possible, it will be a bonus, I would say. So if we talk about these key fields, so database keys, now this is just taken from Wikipedia just to show you how many keys there are. This is just some of the keys. There's different names, but we'll get rid of this. I'm going to talk about 3 types of key fields. I would say you need to know these. Again, it doesn't specify, but it really does explain the relationships and how relational databases work. So every table in a relational database should have something called a primary key column, so a primary key field. And it needs to have a unique value for each record, so the primary key needs to be unique. So in this example table, about, what's it about? I think my idea was like the candidate number or candidate ID you write on the front of your exam paper. Yeah, probably. And so if we just want to have a nice definition for a primary key, it's a field or a column that uniquely identifies a record. And so every table should have a primary key column, a primary key field, and so it needs to be unique. And so pretty much anything to do with an ID screams primary key to you, because people don't share IDs, you would hope. And so often, well, I don't know often, but sometimes they are indicated with an underline. But often exam questions ask you what is the primary key field, and really you want to be looking for the unique column. And this can be an issue because, I haven't exactly written much in this example, but you might not have another John Smith in your school, but you could potentially. You're not going to have a different person with the same candidate ID, because that would be a major issue, but you could have someone with the same name, especially if this was split up into your first name and your surname, and people are going to sit the same exam. So if it was a question, I think it'd be quite clear that this needs to be our primary key. And so there are going to be cases where there isn't a single field that is going to be unique in a table, but you do need this kind of primary key nature. And so what we do, we combine two fields together. So this is called a composite key. And a composite key is used to uniquely identify a record using multiple fields. And so an example I thought of was in terms of flights. So the flight number often stays the same. So I think this is for London to New York or something with British Airways. And so every day BA177 leaves London to go to New York. Probably, I don't actually know that, but you'd assume every day this flight with the same flight number leaves the airport. And so on its own, this wouldn't be enough to make it unique, because we've got two records with the same flight number. And so we can combine it with a date. Maybe there's only one flight leaving per day, and so the date can be combined with a flight number, hence both be underlined, to make this composite key. And hopefully composite key explains why it's really important you need to uniquely identify a record. And when we talk about the SQL statements a bit later, it will become quite clear, I would hope. And so when you have multiple tables in a relational database with these different relationships existing between the entities, this is modelled with the shared key fields. So a field in one table that is a primary key a field in one table that is a primary key in another table is called a foreign key. That's important to get right. So a foreign key is a field in one table that is a primary key in another table. And this can be a little bit confusing because really it's about what table you're looking at. So I have run out of space to do a proper example, but two different tables here. And this, if we're looking at this sort of pink purple table, this is our primary key A. I've got it underlined. But when we're connecting this relationship to this table about another entity, so two different entities here, this is now our foreign key. So we're looking at this table, this is a primary key and it's linked to a foreign key in another table. Whereas if we're looking at the yellow table, this is our primary key and it's linked to a foreign key. So it's kind of about perspective in this case. Right, so as I've been saying, we need to look at SQL statements, and SQL stands for Structured Query Language, something you probably want to learn because that could be a question. And so it's really a specialised programming language with special purposes for databases, and so it allows you to create database structures and then manage the data in them. And so this is just from what I showed you right at the start of the video, just part of the specification, so we need to make sure we cover each of these points. As I said, I believe you need to be able to actually write SQL statements in the exam. So likely they'll give you a table, or give you a scenario and ask you to write a SQL statement about that scenario. And so you're not actually going to have to program it, so your syntax probably doesn't have to be perfect. Structured SQL is relatively standardized. It's not perfectly standardized, so there are slightly different syntaxes. So I imagine you won't get penalised massively, but I'm going to be using the exam board syntax from the appendix of a specification in these examples, and this is also from a specification just to remind you of the comparison operators to do with SQL. Maybe the one you need to know is this one, although we did a operator video, didn't we, so you might remember this. Also, just to one specific to SQL, a little asterisk is something called a wildcard operator, and it just means all, so it might be select all from a table instead of having to write out every field, and null just means there's nothing existing there yet. So the first one we need to look at is insert, and so this is going to enter a new record into the table and store the values in the columns. So this is kind of a generic example. So the first thing we can say from this, and you're going to have to potentially replicate this in the exam, so you want to do this so the insert into is in capitals, as is values, and we have our semicolon at the end of our total block of code. And so what we're doing is, this is our table name, so we're inserting into this table these values in these fields, and this is just trying to show that you can go on, obviously. So these are our fields, these are our columns, and these are the values that are going to go into the rows, if you want to think of it like that. And so they're done with quotes. You can have a single quote instead of a double quote, and you'd write your values, and so this value is going to go into this field, this value is going to go into this field, and so on if we added more fields and values along. And so this is entering data into specific fields. Okay, let's just use the null, for example. So if you were doing this process but you didn't want to enter anything into field 2 yet, you could just write null here instead. But anyway, if you're entering data for every field, you don't need to write out all the field names, e.g. you can just do insert into your table name and don't have to bother specifying for fields if you're going to write everything, all values for each field. So you need to make sure you write a value in for each of the fields you have in your table. But this is assuming we have a table already, so I might as well just talk about creating a table. As I said, SQL can be used to create database structures, and this is also on the specification, so in fact this is just a screenshot from a specification. So this is our sort of generic form. It's pretty worth showing you an actual example of what it might look like, because this doesn't really make a massive amount of sense potentially. So what we're doing here is saying we're going to create a table called student, and this is us specifying our column names or our fields. And so the first one is called student ID, and this is saying that this is the data type. So the data type is varchar, which is a variable character. So it's basically a variable string, so it can be of any length up till 10. So this is our maximum length, and I've set this at 10. And so this is going to be our ID. The student age is another field, and this is going to be integer because the age is going to be integer, and there's no length for this, so it doesn't have to have that. And also we're designating the student ID as the primary key. So this kind of shows you the primary key isn't just assumed, you have to actually say what your primary key is going to be. And again, we end it with our semicolon. That's quite important. So moving on to look at some other ones. So it talks about amending data. So first of all, updating data. This is instead of, so inserting is to basically add a new row to the bottom of the table, whereas we might want to just change some data already in the table. And so to do this, you need to specify the table and field like before, but also a piece of data that needs to be updated, and the value, of course. So this is our generic bit from the specification. So you need to write update just for single keyword in this case, again table name, and then another keyword, set, and in brackets we write our field name or column name, and equals our value or values depending on how many columns, and then we need a condition as well. So again, let's do a proper example here because it'll make more sense. So if we want to update our student table we just created, and we want to set the student age to 19, but which student age? There's lots of different records corresponding to this field, so we need to specify which record we're changing, and so we need to have a where clause. So we're going to say the student ID, we want to change it when the student ID is this. So really we're saying we want to update the age of this student with this ID. That's what this code is saying. And to delete I'll explain this in a second because I know what's coming. So another way to amend data is just to delete it. And so to delete a specific record, you could use just a condition like the where condition, or this wildcard operator, as we call it, to delete all the table records. So just to delete everything, delete all from table name, just gets rid of all the records. But you could just delete some records. And so in this example, so again, delete from are our two capitalized keywords, our table name, and then our condition is this. So we're now using one of the operators previously. So student ID is less than 200. So this might be just to remove a class. The class that was just left might have the ID 1 to 200, so you want to get rid of it. And so this is as we just looked at, the student ID in this example is our primary key, and the primary key is perfect to use here because it's unique to this individual record. It makes sure that only this record is changed. So if we say where the student name is John Smith, there could be more than one John Smiths in the school or university, and so using the student ID instead for primary key ensures that only this record is changed. So only this record is updated to 19, or only these records are deleted, not just all of them. So that is probably quite a key point, that we're using a primary key as our field to make this condition. Okay, so the final type of statement to look at is a query, and as we kind of said, this is used to fetch/sort data. And so this is our generic kind of template. Again, let's look at a proper example. So firstly, we've got an extra line here that we've had before, and this is order by. So these two keywords sorts the records in ascending order by default in SQL, but if you want to change this to descending, then you just add desk to the end of it. So if it's like a string, it'll be alphabetical, ascending, so A to Z. If it was numerical, it would be low to high. That's what it means by ascending or descending. So let's look at a proper example. So this is selecting two fields, so two columns, name and address, from a customer database table. So I guess what I was thinking of this example is maybe if they want to get some market research on some customers. So say that this is a shop that has a store in Manchester. They want to find out what people were doing, or I don't know, I haven't really thought it through, but they want to select both people who maybe shopped in the Manchester store and on this day. And so we're using a Boolean operator now, and we've looked at these quite a lot, and we're going to look at them in the logic topic coming up. But we need both to hold in order to get this data back, to select it from a database. So we're fetching the data. And so finally, we're going to order it by descending, and using the column name, you can have multiple columns to order. But this is our complete SQL block of code. That's it for this video, quite a long one. I've tried to keep the video lengths down recently because they've been getting quite long. Yeah, thank you for watching.